Hello, this is Miss Billerbeck, and we're going to talk about the Cartesian coordinate system created by René Descartes. You don't pronounce the S because it's French. So he was a Frenchman, and he, believe it or not, he created this by watching a fly on the ceiling, and he wanted to know how to explain the location of where the fly was landing each time. So he came up with a very unique way called the Cartesian coordinate system. So section 10.1. So let's talk about what is this Cartesian coordinate system. So with the Cartesian coordinate system, we have, let me turn this the correct way. We have an x-axis down here and a y-axis. This is called the independent axis. And we use this, we think about things that are independent. So those are things we can't control. Okay, well, right now we're in a lot of things that we can't control, like the spread of, well, we can kind of control the spread of coronavirus, but anyway, we couldn't control the fact that it occurred. But we can at least stay home and be safe. So that'd be something that would be independent. But things that normally are independent are time. Time marches on no matter what we do. So, so we look at time, and then things that are dependent this is the dependent axis. Okay, so a dependent would be if you threw the ball with a certain force, how high would it go? So height. Okay, depending on how much time you put into your homework, it would be a grade. Would be dependent. Whoops, let me spell grade right. So there you go. We have a few things that could be dependent on our actions. I'm really glad that you're watching this, though. I do miss you all. So anyway, so René Descartes, he created this coordinate system where if I have a point here, this point will be described in terms of x first and then y. So since if we have this counted out, and let's just say 2, 4, 6, 8, 10, and then this is 2, 4, 6, 8, 10. So this point would be located, oh, look what I did. It's at 7, 7. So if we come up here, it's at the 7 on the x, and if we come here, it's at 7 on the y. Okay, but this point over here, this point, its coordinate would be, we're right at 10. And if we go over to our y-axis, it's at 3. If we choose a point down here, then this would be -2, -4, -6, -8, -10. We would have the x is at 2, and the y is at -6. And then if we had a point way out here, so we're going to write -2, -4, -6, -8. negative 10. So this one comes up here at negative 9 on the independent axis and at negative 4 on your dependent axis, your y-axis. And another point over here, let's say, how about right by the grade? Okay, so we have negative 8 and negative 5. All right. So that's how we would define the points. So if you notice, there's 4 different parts of this Cartesian coordinate system. So let's look at what those parts are. Some of you already know them, but we have our y and our x-axis. So this is called quadrant 1. And in Roman terms, we just write a 1. Okay, this one's called quadrant 2. So quadrant 2, and we denote that with the Roman numerals like that. This one's quadrant 3, and it's denoted with 3. You guys should be good at this with all your Latin. And then quadrant 4 is IV. So it's quadrant 4. So normally we denote the quadrants with Roman numerals, and it goes counterclockwise because when we usually spin, we spin from this direction. When we do angles, we go around this way. So that's why we do the quadrants in this direction as well. All right, so let's look at a few coordinates and try to plot them. Okay, so let's say we have R, and R's at 1, 3. We have S at negative 2 and 3. T is at 0, negative 1, and U is at 2, negative 2. So let's plot those. First, we label our axes, y and x. We start labeling. We're not going very far, so let's just we can change up our axis labels as we see fit. I think this one would be better for us since these points are not, way out. So let's see. So first we label our axes, and that is our choice. It's our freedom to label our axes as we should see would best fit the data. Okay, so since this data is going to be closed, I'm spreading it out. So if I were to go to 1 on the x and 3, 1, 2, 3, this coordinate now is 1, 3, which is R. Now at negative 2, That's on the X. So 1, 2, and up 3. 1, 2, 3. So this one's negative 2, 3, and this is S. T is at 0, negative 1 right here. So this one's 0, negative 1, and that's T. And U is at 2, 1, 2, and then negative 2, 1, 2. So 2, negative 2 is U. All right, so that's how we would plot a few points. So now you should be ready to do a few of your exercises on 10.1. Have a great day and be well.